Quiz 1, question 4. Mr. X will retire in 10 years and currently has $200,000 in his retirement account. He assumes that he will live for up to 20 years after retirement. So he'll work 10 years and then live for an additional 20 years after he retires. During those 20 years, he projects annual expenses of $50,000. If the interest rate is 7%, how much does he need to deposit annually for the next 10 years? Assume the deposits before retirement and withdrawals or after retirement occur at the beginning of the year. Okay, so the contribution is at the beginning of the year as well as the deduction when in retirement. So we know our rate's 7%. We need to figure out what the contribution is. So what will happen at the end of year one, we'll have the $200,000 in there to earn the 7%. And so what that's going to look like is our amount C4 times 1 plus our rate of return. We'll hit F4 to lock that in. And so assuming no contribution, there'll be $2,114 in that account. Now notice what's happening here. Assume the deposits are before retirement and withdrawals occur at the beginning of the year. So technically what could happen here is you could say, well, there's a deposit and you'd think it gets a 1-year rate of return. So this is the one place you have a source for error. But the way you would think about this is you have this amount plus your contribution. Okay. So we take that all the way through and to see how large the money goes. And then we would put in here some guess amount. So let's just guess $10,000. So then what happens once we hit retirement? So after 10 years, we're going to retire. So that means then there's a remaining 20 years, years 11 through 30 of retirement, and then by year 31, our gentleman, Mr. X, will conveniently retire or expire. So now what we need to know is what's happening to the cash flows here. And so now, rather than getting a contribution, we're going to have D15, a withdrawal. Now, one thing I noticed here is that this contribution wasn't locked in, so we need to lock that in. So we can see, yep, by year 11, the money's coming out at the beginning of the period, and then it's calculating a growth of 7%. So we can take this all the way down, and we can see where we end up. So there's our formula there. So we're trying to end up with a zero balance there. We could just guess. So we could guess 11,000. See, well, still not enough money. We can guess 12,000. See, there's not money. So we could repeat this process over and over again. We could do 11,5. Okay, 11,5 is not enough. We can go 11,7. Okay, we're really darn close. So it's somewhere in 11,7. Do 11,750. You can see, okay, we went too high because it's a positive balance. So we could do this iterative approach where we go higher, lower, like we're on The Price is Right. But the easier way to do it is we look at our end amount down here at year 30, and we'll use the solver tool, or we can also use the what if analysis. And what we want to do is we want to change cell C34 down here to a value of 0 by changing the contribution right there. And so we have different methods. Use Newton-Raphson. Well, if we went to a what if, there's other ones, but we'll just use nonlinear. And it solves, and we can see 11,726 is the solution. And so what happens is you can see down here, we end up with a zero balance. Now, one thing that I have a problem with is we have a balance in here, and this balance is based on this 200,000 plus a contribution. So really it's like if you made the contribution at year 0, right? This 11,000 went in at the beginning, but that's neither here nor there. So we can see a solution of 1126. And again, the way to approach this is, notice, assume the deposits before retirement and the withdrawals after retirement occur at the beginning of the year. So we have the beginning of the year, it's going up, and then when we calculate for money out, we take the money out at the beginning and then apply our return. So the 50,000 comes out, then we calculate our return. And then we just need to, at the end of the period, end with a 0 balance once the 50,000 comes out. So you can see what's happening is we have 50,000 left over. If we take 50,000 out, well, 0 times 1.07 is still going to be 0. Okay? All right.